There is a direction switch on every ceiling fan in your home right now. It sits on the motor housing, usually a small toggle or slide switch, positioned near where the blades connect to the central hub. That switch reverses the rotational direction of the fan blades, changing the airflow pattern from downdraft to updraft or vice versa. 98% of people never touch it after installation. The fan spins the same direction year-round, pushing air downward in summer and winter identically. But running a fan in the wrong direction during winter forces your heating system to work 30 to 40% harder to maintain comfortable temperatures. Your furnace cycles constantly fighting against airflow patterns that push warm air up toward the ceiling and pull cold air down to floor level where you actually live. The result is a room that feels cold despite the thermostat reading 72 degrees. Your furnace runs longer, your gas or electric bill climbs, and you never realize the ceiling fan you installed to save money is actually costing you hundreds of dollars every winter because nobody explained that the direction switch exists for a specific thermodynamic reason. This is the story of ceiling fan operation, how rotating blades in the wrong direction during heating season can double your energy costs, and why the fan industry prints installation manuals that mention the switch exactly once in fine print on page 11 where nobody will ever read it. Right now, warm air is rising to your ceiling and staying there. This is not opinion. This is physics. Hot air is less dense than cold air. Buoyancy drives it upward. In a room heated to 70 degrees, the air temperature at ceiling height can measure 78 to 82 degrees, while the air at floor level sits at 64 to 66 degrees. That 8 to 16 degree stratification means your living space, where you sit and stand, remains uncomfortably cool, while the upper 12 inches of your room, where nobody spends time, stays excessively warm. Your thermostat, typically mounted at wall height around 5 feet, reads somewhere in the middle. It thinks the room is fine. But your feet are cold. Your body feels chilled. You turn up the thermostat another 2 degrees. The furnace runs longer, heating air that immediately rises to the ceiling and contributes nothing to your comfort. Your heating bill climbs by 15 to 20% for every 2 degrees you raise the thermostat. Over a winter heating season, this stratification problem costs the average household $200 to $400 in wasted energy, heating the cubic feet of air near the ceiling that provides zero warmth to occupants below. Let us go back to when ceiling fans were designed and how they were intended to operate seasonally. In the early 20th century, before air conditioning became widespread, ceiling fans were installed primarily for summer cooling. The blades rotated counterclockwise when viewed from below. This rotation pushed air directly downward, creating a breeze across occupants that enhanced evaporative cooling from skin surfaces. The wind chill effect made people feel 4 to 6 degrees cooler without changing actual air temperature. This worked perfectly for summer comfort. Then central heating became standard in homes. Engineers realized ceiling fans could serve a second function during winter if the blade rotation reversed. Clockwise rotation, when viewed from below, pulls air upward along the fan axis and pushes it outward and downward along the ceiling and walls. This gentle circulation pattern redistributes the warm air trapped at ceiling height back down to living spaces without creating a direct breeze that would make occupants feel cold. The warm air recirculates, temperature stratification decreases, the room feels warmer at lower thermostat settings, heating costs drop because the furnace maintains desired temperatures with fewer cycles. This is not theoretical. This is measurable thermodynamics documented in HVAC engineering studies conducted over decades. But here's the problem. The direction switch that enables this seasonal functionality is almost never explained to homeowners during installation or purchase. Ceiling fan packaging includes installation instructions focused on mounting hardware, electrical connections, and blade assembly. The direction switch receives one sentence, usually something like, use the reverse switch to change rotation direction for seasonal operation. No explanation of why, no diagram showing airflow patterns, no instruction on which direction for which season. The manual assumes you already understand thermodynamics and airflow management. Most people do not. They install the fan, verify it spins and produces airflow, and never think about it again. The fan runs counterclockwise year-round because that is how it operated when first turned on. During summer, this is correct. During winter, it actively sabotages heating efficiency. Industry data from fan manufacturers shows that approximately 70% of ceiling fans never have their direction switch changed after installation. 70% of households with ceiling fans are heating their ceilings instead of their living spaces from November through March every single year. This is not accidental ignorance. This is systematic information suppression through deliberate omission. Fan manufacturers benefit when products operate inefficiently because frustrated customers replace equipment more frequently. Utility companies benefit from higher heating consumption because revenue scales with usage. HVAC contractors benefit when furnaces run excessively because it accelerates wear and generates service calls. Nobody in the value chain has financial incentive to educate you that flipping one small switch can reduce heating costs by 20 to 30%. That knowledge costs them money, so it stays buried in fine print, mentioned once and forgotten, while you pay hundreds extra every winter fighting physics that a 2-second switch flip would solve completely. Here is exactly what you need to do right now. Walk to the nearest ceiling fan in your home. Look at the motor housing where the blades connect, find the small switch, typically labeled forward and reverse, or simply showing directional arrows. Note the current position. Now look up at the fan blades. Turn the fan on at low speed. Watch which direction the blades rotate. If you can see the leading edge of the blades moving from your right to your left, the fan is spinning counterclockwise. This is summer mode. It pushes air straight down, creating a cooling breeze. If the leading edge moves from your left to your right, the fan is spinning clockwise. This is winter mode. It pulls air up and circulates warm air down along the walls without creating a direct breeze. During heating season, November through March in most climates, your fans should spin clockwise at low speed. During cooling season, May through September, fans should spin counterclockwise at whatever speed creates comfortable air movement. The temperature difference is immediate and measurable. A homeowner in Minnesota ran a simple test. She measured floor-level temperature in her living room with the ceiling fan running counterclockwise in January. Temperature at ankle height was 63 degrees, despite the thermostat set to 70. She switched the fan to clockwise rotation and let it run for 30 minutes at low speed. Floor temperature rose to 68 degrees. The thermostat stayed at 70. The room felt noticeably warmer. Over the next month, her heating bill dropped by $62 compared to the previous January. The only change was fan direction. The furnace ran fewer cycles because warm air recirculated instead of pooling uselessly at the ceiling. Over a 5-month heating season, she saved approximately $300. Over 10 years, $3,000 saved by flipping a switch nobody told her existed. The effect compounds across multiple rooms. A home with ceiling fans in living room, dining room, and 3 bedrooms has 5 fans total. If all 5 run in wrong direction during winter, the heating penalty multiplies. Each fan pushes cold air down and warm air up, forcing the furnace to compensate across the entire house. Switching all 5 to correct winter rotation reduces whole house heating load by 25 to 35% in homes with high ceilings where stratification is most severe. A household spending $800 per winter on heating can reduce that to $520 simply by reversing fan direction, $280 saved annually. Over 20 years, $5,600. The fans themselves cost between $80 and $200 each. Even if you purchased fans specifically to enable winter heat recirculation, payback occurs within the first heating season. Everything after that is permanent savings requiring zero effort beyond flipping a switch twice per year. Now, some will say they tried reversing their fan and felt a cold breeze that made the room uncomfortable. This happens when the fan speed is too high. Winter operation requires low speed only. The goal is gentle circulation that redistributes air without creating perceptible breeze at occupant level. Set your fan to the lowest speed setting. If you still feel air movement, the fan may be too low or the room too small for effective winter operation. Most fans work best in rooms with ceiling heights of 9 feet or greater, where stratification is significant enough that recirculation provides measurable benefit. In rooms with standard 8-foot ceilings, stratification is less severe and ceiling fans provide minimal winter benefit. Focus winter fan use on great rooms, vaulted ceiling spaces, and any room where you notice cold floors despite adequate heating. Pair ceiling fan winter operation with basic thermostat management and savings multiply. Lower your thermostat 2 degrees from normal winter setting. Use ceiling fans on low clockwise to recirculate warm air. The combination of lower set point and improved circulation maintains identical comfort at significantly reduced heating cost. A home normally heated to 72 degrees can feel equally comfortable at 70 with proper air circulation. That 2-degree reduction saves 10 to 15% on heating costs immediately. Add another 10 to 15% from eliminating stratification through correct fan operation. Combined savings reach 20 to 30% of total heating expense. A household spending $1,000 per winter on heating reduces that to $700 through thermostat adjustment and fan direction. $300 saved every year from free changes requiring no equipment purchase. Install programmable thermostats to automate temperature reductions during sleep hours and away periods. Heat to 68 degrees during waking hours with fans recirculating air. Drop to 62 degrees overnight when occupants are under blankets and ambient temperature matters less. Return to 68 1 hour before waking. The furnace runs minimally during 8-hour sleep periods. Ceiling fans maintain adequate circulation during occupied hours. Total heating costs drop 30 to 40% compared to maintaining constant 72-degree settings without air management. A family in Colorado implemented this strategy. Programmable thermostat set to 68 during day and 62 at night. 5 ceiling fans switched to clockwise winter operation. Previous winter heating cost was $1,400. Following winter with changes implemented cost $840, $560 saved in one season. The thermostat cost $90. The fan direction switches cost nothing because they already existed. Total investment $90. Payback in under 2 months. 18 winters of continued savings after that before any equipment replacement needed. The knowledge did not disappear because it stopped being effective. It was systematically excluded from mainstream home comfort advice because informed customers who optimize heating efficiency, reduce utility revenue, eliminate unnecessary HVAC service calls, and stop purchasing supplemental heating equipment to solve comfort problems that free solutions already address. Your grandparents understood that hot air rises and needed redistribution. Homes built in the early 20th century included transom windows above doorways specifically to allow warm air trapped in upper rooms to flow into hallways and recirculate. Ceiling fans with reversible motors were marketed explicitly as seasonal comfort devices that cooled in summer and distributed heat in winter. For decades, this was common knowledge. Then central air conditioning eliminated summer ceiling fan necessity in many climates. Marketing shifted to focus purely on cooling breeze effect. Winter functionality disappeared from advertising and consumer education. Manuals still mentioned the direction switch because engineers knew it mattered, but nobody explained why anymore. The information became buried knowledge that benefited you enormously but profited nobody else. If this just revealed $200 to $400 in annual heating savings from a switch you flip twice per year, share it with someone who complains their house feels cold despite the thermostat set to 74. Every person who operates ceiling fans correctly is one less customer wasting energy heating their ceiling. Every home that recirculates warm air is a permanent break from overpaying utilities to compensate for physics working against comfort. The next hidden solution addresses something even more wasteful about water heating temperature settings. And what it reveals will permanently change how you think about an appliance that runs constantly, costs $60 to $90 monthly, and operates 15 to 20 degrees hotter than necessary because of a factory default setting nobody tells you to adjust.